So here we have a quadratic relation, and if we were to graph it, we know that it would look just like this quadratic relation, but it would be shifted left 6 units. Here's a graph of it. Now we can rewrite this quadratic relation by expanding this right-hand expression. This looks like a binomial to us, and it's being squared. If we expand that, we'll get x squared This quadratic relation has the same graph as the original. If we compare the two in Desmos, just to be sure, we can put in both. And we see that they are the same graph. Here's another quadratic relation. This one appears to be shifted to the right 7 units. It's upside down, and it's stretched vertically, so it's a little bit thin. So if we expand this expression, the first thing I'm going to do is expand this squared binomial. So I get x minus 7 times x minus 7. At this point, I can multiply all the terms inside the brackets by -2. We recognize this as the distributive property. If it helps you to draw those little arcs to keep track of things, do that in your notebook. I like to do it in a different color. Negative times a negative times a positive, and we have our alternate quadratic relation. So if we took a look at the graphs, so there's the original one, and the expanded one is the same. You can turn these on and off. Very similar to the last question, except that I have a subtract 8 at the end here. I'm going to do all these steps first and this one last according to bed mass. I'm going to handle my exponents, then my multiplication, and later I'm going to do my subtraction. Multiplying by 3. Now I can group like terms. once again, when you compare the graphs, they are the same. They are the same relation. They're just in a different form. So in general, we say that this is vertex form, and we call this standard form. Why do we call this vertex form and this standard form? We look at the vertex form and we look at the graph. When it's in vertex form, it's very easy to read off where the vertex is. The vertex is at 5, -8. And we can tell that just by looking at the relation because we know it's been shifted 5 to the right and 8 down. So we call this vertex form and we call this standard form.